Section 9.3 is going to be going over the area of trapezoids, kites, and rhombuses. And these are all very closely related to each other. The first one, the area of a kite, is going to be, whoops, sorry about that, 1/2 times diagonal 1 times diagonal 2. So it does not matter which one you label diagonal 1 and which one you label diagonal 2. But you do want to make sure you are going the entire distance from one vertex all the way to the opposite vertex. So there's going to be a horizontal diagonal and then a vertical diagonal. Sometimes you're going to have to add numbers together to get that length, but you just, again, want to make sure you're using the entire length of that diagonal. Rhombus also has the same formula, where your area is going to be 1/2 times diagonal 1 times diagonal 2. And with this one, again, you want to make sure diagonal 1 is the entire distance from one vertex to the other, and then diagonal 2 is the same thing. One thing that might be useful for these two shapes to know is remember all the way back to our quadrilateral unit, the diagonals in a rhombus are bisected. So both of these are cut into two congruent parts in your shape. So if you know half of it, you know the other half as well. And then in a kite, the shorter diagonal is bisected. So these two parts would be the same length. All right. Then next we have the area of a trapezoid. So a trapezoid was again another type of quadrilateral. It has one pair of parallel lines, and then in this shape, those are going to be called our bases. So base 1 and base 2. And it's okay, you can label whichever one that you want. The area formula for this is going to be 1/2 times the height. And just like with a triangle, we want it to be the vertical height. Do not use the slant height. Okay. So this one is 1/2 the height, and then we are going to take base 1, whatever that length is, plus the length of base 2. Awesome. So then that gives us our 3 area formulas. Okay, so we're going to use those formulas to find some areas. Example 1, the free throw lane on an international basketball court is shaped like a trapezoid. So right away we know that we are going to be using the area formula for a trapezoid. And you will be given all of these formulas on a quiz or a test, so you don't have to worry about memorizing them. You just need to know how to use them and how to find the information that's part of the formula. They want us to find the area. So our area formula is the 1/2 the height times base 1 plus base 2. And we'll plug in all of that information. The height they gave us is 5.8. Base 1, I'm going to use 3.6, and base 2, I'm going to use 6. So our area is going to be 1/2 times 5.8 times base 1, 3.6, plus base 2 of 6. All right, now you can type all of this into your calculator exactly like that. Or you can simplify before. It is up to you. When you type it in, typically people type it in like this, where they have 0.5 times 5.8 times, and then you have to make sure this part is in parentheses, or you have to add them before you put it in your equation. So again, it's really important that you either add these or put them in parentheses when you type it into your calculator. All right. And with that one, once you type it in, you would get the area of 28.42, and the units were meters, so we would have meters squared. All right, so that is an example of how you would find the area of a trapezoid. All right, next, example 2. The rhombus PQRS represents one of the inlays on a guitar in the photo. They want us to find the area. So our area formula for a rhombus, you would be able to look that up on your formula sheet, and it's 1/2 diagonal 1 times diagonal 2. So remember, the diagonals of a rhombus are cut in half. So if you know one part, you know the other part. Same thing on our second diagonal. So if we look, diagonal 1 is going to be going from the top to the bottom of our shape, and each of those parts are 9. So one of our diagonals will be 18, and then the other diagonal is going to be horizontal, and each of those parts, it shows us are 12, so the entire diagonal would be 24. So when we plug that into our area formula, we would have 1/2 times 18 times 24. And again, most people would type this into their calculator as 0.5 times 18 times 24. And once you type that in, you should test it out just to make sure you are typing it in correctly. You should get 216 millimeters squared. All right. So then our next example, you should pause and then try to find the area of these different shapes. Okay, for our first one, this one is again a trapezoid. So our area formula is 1/2 the height times our bases added together. And when you plugged in all of your values, you should have had 1/2 times 4 times 8 plus 6, or 6 plus 8. Both will get you the same answer. And once you typed that into your calculator, you should have got the answer of 28 feet squared. Then for example 2, this one is a kite. I'll just write the names up here. So once we have our kite, we know that area formula is 1/2 diagonal 1 times diagonal 2. This one, they gave us both of the diagonal lengths, so you don't have to worry about adding anything together to get those lengths. And it doesn't matter if you put 1/2 times 6 times 14, or if you put 1/2 times 14 and then times 6. Both will get you to the same answer at the end. And that would end up being 42 inches squared. Then the last example here, this one is a rhombus, and the way we know it's a rhombus is because all of the sides of our shape are equal. And our area formula for that is the same as a kite, diagonal 1 times diagonal 2. And this one, they only gave us half of the diagonal, so the vertical diagonal, the total would be 60, and then the horizontal diagonal would have a total of 80. So when you plugged it into your formula, you should have had 1/2 times 60 times 80 to get your answer. And when you type that into your calculator, you would get 2,400 meters squared. Now, all of these came out as whole numbers. That's not always going to be the case when you find your area. So just make sure that you are rounding to 4 decimal points if necessary on these problems. They won't always be a whole number. All right, so then we have a couple examples on the back where we have word problems. So example 3, one diagonal of a kite is twice as long as the other diagonal. So let's draw a picture. So we have a kite, and we have one diagonal is twice as long as the other. So if I say my horizontal diagonal is x, my vertical one would then be 2x. And it doesn't matter which one you label x and which one's 2x. They told us the area of the kite is 72.25 square inches. What is the length of the diagonals? So we are going to plug everything we know into our area formula. And the area of a kite is 1/2 diagonal 1 times diagonal 2. So that 72.25 would be equal to 1/2, and I'm going to use 0.5 because that is typically easier for people to work with. And then one of the diagonals was x, and the other one was 2x. When you have a problem where you are multiplying both numbers and variables together, you are going to start by multiplying the numbers. So 1/2 times 2 is 1. Oops. And then you're going to multiply the variables together, x times x. And this is where a lot of people get the answer wrong, is because they forget that is x squared. So we don't really need to put that 1 up front because 1x squared is the same thing as x squared. So once we're here, we can take the square root of both sides, and that will give us our answer for x. And when we take the square root of 72.25, we get 8.5 equals x. And with these, you want to make sure you don't just find x, you answer the question. So they want the length of the diagonals. So diagonal 1 would be 8.5. And then our second diagonal was twice as long as that. So if we take that times 2, we would get our answer of 17. And both of these would just be inches because they are lengths. So take all the information you know, substitute it into your area formula, solve for your variable, and then again, don't forget to answer the question at the end. All right, these next 3 questions are all review from 9.1 or 9.2. So number 4, what is the sum of the measures of the interior angles of a 35 gon? So because it's the sum of the interior angles, that formula is n minus 2 times 180. And this is one that you have to have memorized. With that sum, we know it's a 35 gon, so that tells us n equals 35. We would have 35 minus 2, and then that answer times 180. And once we type that in, we would get our answer of 5,940 degrees. Then, next, example 5, what is the sum of the measures of the exterior angles of a 19 gon? So the sum of the exterior angles, it does not matter how many sides your shape has, it's always 360 degrees. So there's no work required for this problem because it's just a fact that all of the exterior angles will add up to 360. So your answer is 360, and there's nothing else you have to do for that problem. All right, example 6. What is the area of the regular polygon? All right, so for your area formula of a regular polygon, it's 1/2 apothem times perimeter. They don't give us any of that information in this. So we're going to go ahead and start solving for this triangle. So I'm going to draw my triangle separate on the bottom. And I know the radius is 12. And once I draw my apothem in there, it cuts our side of our regular polygon in half. So each of these are going to be congruent, and I'm going to label both of them X's. And we're going to work with just the right triangle. I'm going to use the one on the right side. Before we can solve for our apothem or X, we have to figure out what this angle measurement is here at the top. So to do that, we are going to find our central angle first. And to get your central angle, you take 360 divided by the number of sides. And this one has 1, 2, 3, 4, 5, 6 sides. So 360 divided by 6, that's going to tell us that each central angle is 60 degrees. So that's the angle between the two radiuses. Once our apothem is drawn, that angle is cut in half. So we would divide that by 2 to get 30 degrees. Once you know that angle, then you can use SOHCAHTOA to help you find the apothem and the X value. It might be helpful if you write SOHCAHTOA and then label your triangle. In this one, X is opposite, 12 is our hypotenuse, and A is the adjacent. I'm going to start by finding my apothem. So that is the A value, or the adjacent side, and we're going to use the hypotenuse with that. So to find the apothem, we are going to be using cosine, and it would be cosine of 30 equals A over 12. Then to get A by itself, I just multiply both sides by 12. With this, you're not going to type it into your calculator yet, because this is not our final answer. So we're just going to leave it that the apothem is 12 cosine of 30. Now, using the same triangle, we are going to then find the X value. And X is the opposite side, And we're going to use that in our hypotenuse because we know the length of the hypotenuse. So the one using opposite and hypotenuse is sine. And when we set that up, we would set it up as sine of 30 equals x over 12. And again, to get x by itself, this time we're going to multiply both sides by 12. And that gives us 12 sine of 30 equals x. Now, this is where some people will then plug this into their area formula as the perimeter. But remember, this is only the length of x. And if we look, that's half of our side. So there are actually 2 x's for every side of our shape. So if we look around our entire shape here, we have a total of 12 x's. So to get our perimeter, we are going to take this times 12. And when we do that, we still want an exact answer. So you are only going to multiply the number in front of sine times that 12. And that gives us the perimeter of 144. And then the sine of 30 just stays the same, sine 30. Now we have an exact answer for our perimeter and an exact answer for our apothem. Once we have both of those, we go back up to our area formula and plug everything in. So for this problem, our area would be 1/2 times 12 cosine 30, because that is our apothem, times our perimeter of 144 sine of 30. Then we plug that all into our calculator. Oops, sorry, I typed the wrong button here really quick. 12 cosine of 30 times 144 sine of 30. And again, I would practice typing this into your calculator to make sure you are getting the correct answer, because typing it into the calculator and knowing the equation are 2 very different things. So you want to make sure you can do both on your quiz and your test. So this one, when we plug it in as 0.5 times 12 cosine 30 times 144 sine of 30, you would get the area of about 374 point, and then 1230 when we round it. And that would be our area. Okay, so that is everything for 9.3. If you